This presentation shows how to lay out a set of geophones and connect up a geode seismograph to make a simple seismic refraction survey. Best practice in seismic surveying state that geophone positions should be accurately surveyed in for both X and Y locations, and if topographic corrections are required, elevations as well. But for brevity in this presentation, it is assumed that this step is completed. Here, the field operator is laying out the geophones in their approximate positions prior to accurate planting in the ground. Once accurate positions for the geophones, or phones for short, are located, they can be planted in the ground. It is important that the spike is pushed into the ground as far as possible, and the geophone is kept as vertical as possible. If necessary, any loose turf needs to be cleared to allow the geophone spike to bite deeper into the firm soil and achieve the best coupling of the seismic signal with the geophone, and reduce the sensitivity of the phone to wind-generated noise. While it is tempting to stamp on the phones to force them into dry ground, this should be discouraged as it can possibly damage the geophone, and importantly it is difficult to maintain the phone at a vertical position. Lower frequency geophones in particular lose sensitivity if they are not vertical, so a badly planted phone will reduce your data quality, costing you both time and money as your survey may have to be reshot. Here the operator follows best practice and is checking that the geophone is held firm in the ground by gently trying to twist it. The cable which connects the geophones to the seismograph is known as a spread cable and is laid out by walking down the line, making sure that the connectors which mate to the geophones that can be seen here in yellow are placed on the ground next to each geophone. The geophones are connected to the spread cable, making sure that the correct polarity is observed at all times. The wider clip with the red insulator jacket is connected to the wider sprung wire takeout on the spread cable, and correspondingly the black clip goes to the narrow spring on the spread cable. After the geophones have been connected up, the spread cable is connected to the geode seismograph. All of the connectors on the geode are keyed to ensure correct engagement. Here the operator is holding the spread cable connector with the key visible at the top. When mating this spread cable connector to the geode, observe where the corresponding key is on the panel mount connector on the instrument. If correctly aligned, the connector can be easily locked in place. You also see that the power and the other connectors on the geode are keyed to ensure correct location. When in the field, the geode is powered from a 12-volt battery. The battery shown here could power the geode for several field days. When connecting the power lead, ensure that the red clip is connected to the positive terminal on the battery and the black clip to the negative terminal. The geode is an exploration seismograph and needs an external trigger impulse to start it recording. Here we see the lead from the trigger being connected to the 3-pin connector on the geode. It is identified by a hammer icon just above the connector. As often with such seismographs, a sledgehammer is used as our energy source. The final connection that we need to make to the geode is a digital cable which connects to a field PC. Above the connector is a small circle with an arrow pointing out of it. Here the circle represents the geode and the arrow shows that the data is flowing out of it and into the PC. The trigger impulse for starting the geode is provided by a small cylindrical switch known as a hammer switch. This can be fixed onto the shaft of the sledgehammer using PVC electrical insulation tape. When making this fixture, it is important that the black dot on the side of the switch is facing the shaft of the hammer and the switch held securely against the handle, otherwise it may not work correctly and result in lost data. The 3-pin connector on the hammer switch is connected to the corresponding socket on the trigger extension lead. The yellow digital cable from the geode needs to be connected to the network interface connector on your PC. Here, the operator is seen connecting this cable to the geode laptop adapter box, which is an RJ45 connector on the end of a short trailing lead and will connect into the network port on your laptop. The geode laptop adapter has a 3-way switch on it. When turning on the geode, if this switch is in the Enable Power Up position, when booting up the controlling software on your laptop, it will turn on the geode. Once the geode is up and running, you can then place this switch in the Enable Power Down position. This way, when you close the operating software, it will automatically power down the geode in an orderly fashion. When using a sledgehammer source, a striker plate is used in order to couple the energy from the hammer blow into the ground. When placing the striker plate, clear away any loose material from under it to achieve maximum signal coupling. When striking the plate with the hammer, it is important not to let the hammer bounce on the plate, otherwise false triggers can occur. Additionally, the operator can be seen to be taking his weight off the ground at the commencement of the swing. This has the effect of producing a cleaner signal and minimizing such movements which would otherwise occur immediately after the hammer strikes the plate and which would couple into the seismic signal, which is an unwanted source of noise. Take care when swinging the hammer to keep the trigger cable behind you, otherwise it is very easy to hit it with the sledgehammer, causing damage which can result in the early termination of your survey unless a field repair can be made.